Hello, in this video, I will explain to you on to find out I1, I2, and I3. So that is our goal. So we need to find out I1, I2, and I3. And how we do that? We will use mesh analysis. So we need to do mesh analysis, and I will explain it to you step by step. The first step that we need to do is we need to label all the loops. Label all the loops. And in the circuit here, we already given that is 3 loops. I1 here, I2, and I3 here. So we have I1, I2, and I3 as our loops. But aside from labeling all the loops, we need also to extract some information available from the circuit. If we see here, this is I0 and this is also I0. So this will be dependent on this current here. But then this current here is the current that passed through this 6 ohm resistor. So I0 is also here, right? But then I3 is also the same current because it is the only current that passed through this 6 ohm resistor. So that is one of the most important information that we can extract. So I0 is equal to I3. And what is the consequences? We know that this one here, 10 I0, will equal to 10 I3. Right? And that will be helpful because we will do KVL for all the unknown loops, and we already have I3 here. It is the same, right? So we need to do KVL at all unknown loops. In our case here, all the loops are unknown. I1 is unknown, I2 is also unknown, and then I3 is also unknown. So we need to do KVL on I1, I2, and I3. Let's exactly do that. So we will have KVL at loop I1. Okay, what does KVL say? KVL said that the sum of the voltage in a loop will equal to 0. But we have to be very careful about the sign. Okay, let's see here. Let's start from this 16-volt voltage source. And here the current is flowing clockwise like this. And so the current will flow from the bottom side to the upper side like this, right? But this current here is flowing from negative terminal to the positive terminal. So it enters from the negative terminal. So then our sign will be negative. So we'll have minus. And this is already voltage. So we will have 16 here. Now let's move on to this 6 ohm resistor. And the current will go like this here. So we will have plus 6. I mean plus 4, not 6. This is 4 ohm, right? So we'll have 4 ohm. But then there are two currents that pass through it, right? I1 is flowing like this, but then I3 is flowing to the opposite direction like this. But here we are working on I1, so I1 came first. Then I3 is flowing to the opposite direction, so we'll have minus I3. Good. And then now we will have 2 ohm here, and the current will go down like this. And we will have that 2 ohm there. And we multiply it by I1 here. But then here I2 is flowing to the opposite direction like this. So I subtract I2 from it. So we have minus I2. And all of that will equal to 0. Good. Now what can we do from here? We just add them up, right? For I1 plus 2I1, I will have 6I1 here. And then I2 only came from this term, but then minus 1 multiplied by 2 is minus 2. So I'll have minus 2I2. And then this one will be minus 4I3, right? Because I3 term only came from this part here. And let's move this minus 16 to the right hand side. So we will have 16 there. Good. And I think nothing more that can we do from this KVL in loop 1. So let's save this as equation number 1. Good. Now what can we do next? We need to do KVL at loop number 2, which is this one here. Let's do exactly that. So we need to do KVL at I2. KVL said that the sum of the voltage in a loop will equal to 0. Let's start from this 2 ohm resistor here. We will have 2. But then we are working on I2 now. So I2 came first. But let's see here, I2 is flowing up, but then I1 is flowing down. So I subtract I1 from it, like this. And then let's move on to this 8 ohm resistor. I2 will flows there, but here I also have I3 flows there. So we will have plus 8. Remember, we are working on I2, so I2 always came first. And here I3 is flowing to the opposite direction, so we'll have minus I3. Okay, now let's move on to this component here, and the current will flows like this. And here the current enters from the negative terminal, so we will have negative sign, right? And then the value we can enter 10I0, but I want to enter 10I3 instead, right? Because we have I1, I2, and I3. So it's better to enter I3 here. So we will have 10I3, but then I need to move this slightly to the left because I ran out of space. Good. So let's make it 10I3 here. And I think we have done for all the components in the loop I2. So all of that will equal to 0. Good. Now what can we do from here? Let's add them up, right? The I1 term only came from this one, but we have 2 of them with the negative sign. So I have minus 2I1. And then what else? I2 came from this term and this term. And so we will have 2 plus 8. That will be 10I2. And then I3 came from this term and that term. This term is minus 8. And then minus 10. Minus 8 minus 10, that will be minus 18 I3. Okay, and then all of that will equal to 0. And let's save this here as equation number 2. Good. Now let's do the third step here, which is KVL at I3, which is the last loop here. So we have KVL at I3. Again, KVL said that the sum of the voltage in a loop will equal to 0. Let's start from this 6 ohm resistor. So we'll have 6. But remember, we need voltage, so we multiply the resistance by the currents to get voltage. So I will have 6, and the only current that pass through it is I3. Or you can use I0, but I prefer to use I3 because we have I3 in all the variables. Okay, so I will have the next component, that will be 8. And remember, we are working on I3, so I3 always came first. I3 came first, but then here I2 is flowing to the opposite direction, so we will have minus I2. Good. And for the very last component of our analysis, we will have this 4 ohm. So we'll have 4. And then we will have I3. Always I3 came first because we are working on I3. And then here I1 is flowing to the opposite direction. So I have minus I1 here. All of that will equal to 0. Now we can just add them up, right? I1 only comes from this term, so we will have minus 4I1 of them. And then what else? I2 only came from this term, and we have minus 8 of them. So I have minus 8I2. Then I3 comes from 3 places, 1, 2, 3. So we'll have 6 plus 8, that will be 14. 14 plus 8, that will be 18. So we'll have 18 I3. All of that will equal to 0, and we have the third equation. Now we have 3 equations and 3 variables, right? We should be able to solve them. So that is exactly the third step, which is to solve the equations. Okay, and how to do that? I think we will have to use calculator because it looks complicated. Okay, let's clean up our slide first. Okay, we have cleaned up all the, what is it? The calculation. So we have left with these 3 equations and 3 variables. And I think the fastest way to solve the equation, which is the third step of our math analysis, is by using calculator. Why? Because in the circuit analysis course, you usually can bring your calculator to your exam. So why not just to use it to solve the equation, right? So let's set up this as equation solver. So this button here and number 5. And so we will have 3 equations with 3 variables, that is number 2. And what we need to do is we just plug the coefficients of this equation. So we will have 6 minus 2, and then minus 4, and then 16. The second equation will be minus 2, and then 10, and then minus 18, and then 0. And then this one will be minus 4, minus 8, and 18. And finally, we will have 0 here. So we will have our x value, which is the value of I1. So minus 2.571. So I1 will be minus 2.571. What is about the unit? All the unit here is in SI unit. So this will be in SI unit. So this is in ampere. And then what is I2? I2 here is the Y value. So we will have minus 7.715. So we will have minus 7.715. And the unit here will be in ampere. And then what is I3? I3 is minus 4. So we'll have minus 4 ampere. And I think we have achieved our goal. I1, I2, and I3. I1 is this value here. I2 is this value here. And I3 is this value here. So thank you for watching. See you in the next video. Bye-bye.